as we've been talking about conditional statements, remember, first we talked about them in terms of here's the if, there's the then, and when we flip it around, here's the converse, and we talked a little bit more about the truth value of those statements, and we built that into the biconditionals. Those conditional statements also build us into today's lesson when we're talking about deductive reasoning. Let me backtrack a little bit. We have talked about inductive reasoning, remember. First lesson of the chapter had to do with inductive reasoning, which deals with patterns. We see what's happening, and then we conjecture about what will happen next. When we are talking about deductive reasoning, that is a much more general sense, and that is what we do most of in this class. You'll see as we go through this course, a lot of the properties that I give you will be stated in conditional form. In other words, if this is true, then that is true. And the reason why we're doing all of this stuff now is so that you have those tools to use those properties and make those logical conclusions thereafter. In this lesson, we're only going to talk about two laws of logic specifically, and we're going to deal with them in very non-geometric topics, but it's, again, to really cement the idea of when can I make a conclusion and when can I not make a conclusion. So the two laws of logic that we're talking about in this class are the law of detachment and the law of syllogism. Now you see them both pretty plainly in your notes. However, it's symbolic and it's in geometry speak. So it might not be making as much sense to you as I would like. So let me try to translate it for you a little bit more. The law of detachment tells us if I have an if something then something statement, and I know that the if part of it is true, well, I can conclude that the then part of it is true. That should just kind of make sense. So, for example, making the statement, if you pull your phone out in Mrs. Clouse's class, then she will mock you. So, Benjamin pulls his phone out in my class.
Yeah. Well, then.
What logical conclusion can you draw? That I will mock Benjamin, yes. Okay, that is the law of detachment. The law of syllogism looks like it's a little bit more involved, but I don't want you to get so hung up on what it looks like. I want you to realize that it's very much like transitive property from algebra. Let me refresh your memory. The transitive property from algebra says if A equals B and B equals C, then A equals C. Just kind of makes sense. The law of syllogism sounds very much like that. If P arrow Q is a true statement and Q arrow R is also a true statement, I can conclude that, P arrow R is also a true statement. So the big thing that I want to emphasize when you are using the law of syllogism, remember what that arrow indicates. That arrow indicates I have a conditional statement. That arrow indicates I have an if something, then something statement. Okay? So, if I wanted to come up with a kind of real-world example that you could relate to, this is the best I can come up with. If a student does his homework, then he will master the skills. If he masters the skills, then he will be successful on a quiz. My logical conclusion is if a student does his homework, then he will be successful on a quiz. Okay? So let's take a look at a couple of examples using law of detachment and or law of syllogism. In problem 1, we are being asked what we can conclude from the given combinations of statements. In part A, I have, if it is raining outside, then there are clouds in the sky. It's raining today. Can I draw a conclusion? Yes, Christian.
Would it be there are clouds in the sky today?
That's it. That's it. There are clouds in the sky. We could have the today Not necessary, but it's fine. Part B, if Malcolm scores at least 85% on his final, then he will earn an A for the term. Malcolm scores a 90% on his final. Can I draw a conclusion from these statements? Yes. Malcolm earned an A. Feels pretty easy so far, yes? No. So easy, I heard that. Part C, if two angles are vertical, then they are congruent. My second statement is angles 3 and 4 are vertical angles. Can I draw a conclusion? Yes or no? Angles 3 and 4 are congruent. You could express it symbolically if you wanted to. You could say angle 3 is congruent to angle 4. Now it's going to get interesting, and I apologize that this example isn't in your notes and that you have to add to your notes. However, I strongly urge you, make sure that you are in fact adding this example to your notes. I call that example 1.5 because it should have been right between the last example and the next one. If two angles are right angles, then they are congruent. And then I'm told that angle A is congruent to angle B. My question that I've been asking all along is, can I draw a conclusion? And then if so, what is that conclusion? So first of all, can I draw a conclusion? Hope.
Yes.
And this is why I wanted this example in our notes. We actually cannot draw a conclusion from this. If two angles are right angles, then they are congruent. I am told that angle A is congruent to angle B. I cannot conclude that angles A and B are both right angles.
Why not?
Say that again?
Why not?
It could be 180.
They could both be 180-degree angles. Sure, and they would both be congruent. But using my laws of logic to explain why I cannot draw this conclusion, let me reiterate for you what the law of detachment says. Law of detachment says I've got a P arrow Q statement, an if-then statement. And I know that the if part is true. Then I can conclude that the then part is true. Look at these statements again. If two angles are right angles, then they are congruent. In that second sentence, angle A is congruent to angle B. Am I given the if part of the first sentence, or am I given the then part of that first sentence? I'm given the then part. And you have to be ready for that, ladies and gentlemen. I know it sounded like it was wildly the easiest thing you've ever seen in your life, and everything was so obvious. You need to be really careful. Sometimes you cannot draw a conclusion. Let me especially warn you. Sometimes you will think, but it just makes sense. And some of the examples will try to trick you, where I should be able to make this conclusion, Mrs. Clouse. Why am I not allowed to? Because it doesn't follow the law of logic. Okay? So, this has no conclusion. In problem 2, you'll notice that both of those examples have two separate if-then statements in them. Please realize, right out of the gate, when you draw a conclusion using the law of syllogism, your conclusion will be an if-then statement. So looking at problem 2, part A, if a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. My first question again is, can I draw a conclusion? If a number is divisible by 12, then it is divisible by 6. If a number is divisible by 6, then it is divisible by 3. Can I draw a logical conclusion from that?
Would it be if the number 12 is divisible by 3?
Be careful. While I get that what you're saying makes sense, please understand that when we are using the law of syllogism, I have two if-then statements. My conclusion must be an if-then statement. Hold on. You want to try that one more time, or do you want to pass it to someone else?
If the number, like, 12 is divisible by 6, then it is divisible by 3.
You're being specific about 12. It's talking about a number being divisible by 12. Someone else want to try? Kristen.
You'd say if the number is divisible by 3, then it is I don't know.
You're switching it around. Be very careful. Catherine.
If the number is divisible by 12, then it is divisible by 3.
Yes, that is the conclusion. If a number is divisible by 12, then the number is divisible by 3. One of the benefits of you having me after I've already had an honors geometry class is that sometimes I hear something there that I want to make sure that I point out to you. So, one example. Yes.
Do you have a geometry text?
I do not.
Can I take a picture?
Do you have access to the online textbook?
Yeah.
As I was saying, one of the benefits of having me in the afternoon after I've already taught the lesson once is that sometimes I hear something in my previous class and that brings to mind something I want to make sure to talk to you all about. One statement that was given to me this morning when I taught this lesson was, if a number is divisible by 12, then it is divisible by 6 and 3. And that's incorrect. You just completely lose the 6. Please remember, the law of syllogism says if P arrow Q is true and Q arrow R is true, my conclusion, remember, was P arrow R. I don't need to make any mention of that man in the middle, the divisible by 6. The law of syllogism allows us to take those two if-then statements and smush them down into one. And I can leave out the divisible by 6 part. Part B. If a figure is a square, then the figure is a parallelogram. If a figure is a rectangle, then the figure is a parallelogram. My first question, remember, is, can I draw a conclusion? Good. No, you cannot draw a conclusion. What you are looking for when you've got two if-then statements is the then of one statement being the if of the other. And that's not the case in part B, so I can't do a thing with it. I cannot draw a conclusion. Before we get into problem 3, please take a moment and work through the your turns for problems 1 and 2.
So
Begin again. In the your turn for problem 1, one person please. The your turn for problem 1, part A. The your turn for problem 1, part A. If there's lightning, then it is not safe to be out in the open. Maria sees lightning from the soccer field. Hope.
It is not safe for Maria to be out in the open.
Exactly. It is not safe for Maria to be out in the open. Some people might say it is not safe to be out in the open at the soccer field. Something along those lines is fine.
is it okay if we said she cannot go outside?
Don't take liberties. Thank you for bringing that up. Please don't take too many liberties. It is not safe to be out in the open. Make sure that you're kind of sticking to what the sentence says. Thank you for bringing that up, though. Part B, if a figure is a square, then its sides have equal length. and figure ABCD has sides of equal measure, my first question is always, can I draw a conclusion? No, you cannot.
I'll look at that.
No, you cannot.
Okay.
For the your turn in problem 2. For the your turn in problem 2, does someone have? Actually, once again, my question is, can I draw a conclusion?
Yeah.
Yes, you can. And Benjamin?
Yeah. If a whole number ends in a zero, then it is divisible by 5.
Beautiful. Yes. If a whole number ends in 0, then it is divisible by 5. Please, again, remember, make no mention of 10 in your answer. You gotta leave 10 out of it. Now, unfortunately, I don't have problem 3 on my screen, but you have it in the notes in front of you. If you live in Cincinnati, then you live in Ohio. If you live in Ohio, then you live in the United States. Ken lives in Cincinnati. Notice that I've got a few more things going on here than I did in any of the previous examples. So please understand, when I'm asking you, what can you conclude? What I'm looking for is, what is my bottom line conclusion? Right.
Ken lives in the United States.
That's exactly what I'm looking for. Ken lives in the United States. Please don't add any more to that. You don't have to mention Ohio.
Is it because it says Ohio twice?
That's one way to look at it. I do want to make sure to be specific about saying, notice that the Ohio is mentioned in the then of one statement and the if of another. That's why. Okay? All right, I will be activating the daily quiz momentarily. I will be putting the book on the screen momentarily. While those things are in process, please be looking at your turn for problem 3 first.